Yes, students, in this lecture series, we're going to take an overview of a C programming language. We're going to look at the main features of a C programming language that will allow you to start writing simple programs, and then later we're going to get uh, into more depth of these topics in subsequent chapters. So this chapter should give you a very good overview of the features and how do you actually write a C program, compile and run it. And we're going to start looking at the various tools provided to you in the C programming language, like repeated loops, like decision making, if switch statements, and then later in subsequent chapters, we build more in depth of these topics. But already after this session, you should be able to start using the C programming environment to write your programs and then be able to compile and later deepen your understanding in these various aspects of C programming language. Yep. So it's very typical for people who learn C programming language to look at this very simple program here. We're just sending some this text on the screen, hello world. So this is what we're going to do as a first program, and this is already going to be this program will offer lots of insight actually how you write a C program, and then once you can do that, send this simple text hello world on the screen, you're able to now start writing more advanced statements and build up your understanding and the competence in writing C program. So this is a program we are talking about. So we're going to look a bit in more details what are the various components of this simple program here. So first line, this one which is saying in C, the program to print. This is not of other programs, this is just an instruction here. And we found the following line, hash include stdio.h. So this is actually lots of reserved keywords here. We've discussed about reserved keywords before, so the hash include is already a reserved keyword. The stdio.h, so the .h is saying this is actually a file. Standard input output file is a header file. This is why I have a .h. Now, why do we need a header file here? This header file actually contains a library of functions, one of them being printf. So if you look at the program itself now, it starts where main is. So in C program, you will always have a function called main. So this is actually the program which will be compiled and run by the environment of C. So the compiler is going to convert this piece of code into machine language and then run it at execution stage. So of course, in this part of main program, if you have functions now which will be called upon, then of course the functions will of course be compiled as well. But you might have lots of functions written, but not all of them are called in the main program. So what's important here, in all C program, you would have a function called main, and this is what's going to be executed inside the C, inside this main program. If you have functions being called upon, of course, the program will step out of main, go into these functions, passing them any required input and get an output back into the main program and then keep running. So as we look forward again to this, the first program, we've discussed about main. So we'll come back, of course, as we go along on the main program. So first, after main, you find these two parentheses. So it's C, and most of the languages you'll be using the open parentheses here are actually the input argument. So currently is empty, so we're not passing any inputs into the main program. So nothing is being passed into it. On the other hand, if you look at the printf functions, the name of function is printf. You have again the parentheses, opening parentheses, a closing parentheses. Inside it, you have a text here in double inverted commas. So that's going to be the structure of your printf function. Always you have double inverted commas, and then inside it you can put your input to the printf function. So inside this opening and closing parentheses, you have the input to the printf function. Don't worry too much at this point if you don't understand the printf function. We're going to look in more details later. Like I said at the start of the lecture here, we're doing an overview of the C programming languages. So even if you don't get everything understood, if you don't appreciate all aspects at this point, it will come after. So the main objective of this part of chapter of this particular lecture series is to get you started into C programming, and then over time build up your understanding of why you did this and that. Now, next thing we want to look at is when your main program starts, you have the opening curly brace and the closing curly brace. So this is saying the main program starts here, ends here. In this simple program here, just one line. This is why it's a very small program, but of course, you can have any number of statements that sits between the opening and the closing braces here as you start adding more and more complex programs. The number of codes, the number of statements will be 20, 30, or even more. So it's always going to sit between this opening curly brace and the closing curly brace. So this is basically saying the main program starts here and ends here. Next thing we want to look at is, if you look at this printf statement, it ends with semicolon. So all statements in C ends with semicolon. That's also something you need to learn. If you omit this semicolon here, the compiler will flag out an error and will give you some direction where error is coming from. So you need to know that all statements in C ends with a semicolon. Now, last thing is, when you say hash included, can you see the stdio.h is between these two symbols here? Less than and greater than in a way, but it's not actually representing less than or greater than. So in all header files are going to be included in these two less than and greater than symbols. Okay, here we're using only one header file. If we need other functions where we're using other functions which are found in other header files, for example, if you're using mathematical functions, you would need to add the math.h header file, which is provided, of course, as part of the operating environment for C. If, for example, you're using functions with do strings, which we'll do in a subsequent chapter, you need to include a string.h. So all of this would be included in this less than and greater than symbol. So a very good start for us with a simple program here. If you just input that into your C program environment, you compile and run, you should be able to produce the hello world on the screen. So let's do that now. Let's shift to the dev C++ open source programming environment. And to do that, it's going to be a very fundamental step for you to be able to run your programs in the future. So I'm just going to shift to the dev C++ programming environment. Very good. So this is your dev C++ programming environment. So at this point, you say new and you're doing a new source file. So this is how it is. So just basically type what we just seen in the PowerPoint slides. So we have hash include stdio.h. Can you see as of typing the commands in, the environment is going to help you. For example, I just typed one of the symbols to include the name of header file and you put the greater sign for the already. So we're going to see that as we go along. Then we have the main, okay. Then we have an opening curly brace, it puts a closing brace for you. Having it. And then we see printf. I put the opening parentheses, putting the outer parentheses for me, the closing one. If I put the first semicolon, the first double inverted commas, put the second one for me. Things like hello. Wow. So it. In a few minutes, we will talk about the slash n. Okay, so we're going to discuss that. The slash n is actually making when you run this on the screen, it's going to change line and go to the next line. That's why the slash n is a wildcard. So whenever you want to change line, just put slash n. If you want to change two lines, you put two slash n and so on. Okay, so once you've done that, the first thing you want to do is you want to save the file. So you save it in a folder where you have access to. If you save it in a folder where you don't have rights to run any piece of code, any executable files, so then when you start running, it's going to show some errors. So make sure you're saving the folder where you have access rights. Now you want to save it here. You have different file types. You want to save it as .c, and then let's put this one as the first program. So have a couple of others first. Something first .s2.c. So save. Once you do that, you can go to execute in the top menu and then say compile, or you have icon here already, so you compile. Take some time. As you're compiling or running your piece of code, you can actually call your antivirus and you can do some check on the program if there's anything dangerous there, especially when running, you're going to find that. So in this case, we find there are 0 errors and 0 warnings. So once it's properly compiled, then you can just run it. So it's taking some time here, especially it's the first time you're compiling your program. It's going to take some time. And like I said, antivirus could do some checks on the safety of your code, because we know some codes can actually be like viruses, crash your computer and take up memory and start erasing memory. So this is what the compiler is doing. So first time you run a code, it can take some time to show up. So I'm just going to show you the screen now. What is appearing? So it seems the AVG is doing some checklist. So I hope you can see the screen. It's saying hello world and waiting with the cursor and say press any key to continue. So if I just do that, I press enter, so it exits. Now in some versions of this dev C++, you might not have this feature which waits on the screen for you, so the screen can just flash and just come out. So if you get issues like this, I will show you what to do. You can just simply put a statement here which waits for the user to press the character for the program to continue, and that's it, then you could continue. So just to illustrate that, if I run the program again now, it is running faster. First one to 40 seconds to run. This one is taking 0.03361 seconds. So very fast. Once it's compiled properly and not making any changes in your code, it will run faster now. Okay, so do give this a try. Very important for you to get used to writing very simple programs, compiling, running. Now what we're going to do, of course, you will start increasing your statement, the complexity of your instructions. Yeah, so we shift to our PowerPoint slides. Okay, so we just input this program and it's working fine. Okay, so there are lots of information given there, which of course I'm sending you the lecture slides. So do read through. I've explained most of these things written here. What is the main program? The special one or OC program would have a main program. What's the hash includes a keyword, you could header files. In this case, stdio.h is standard input output. So the printf function is found in that library file. So you can find there are blank spaces, so you can use blank spaces throughout your piece of code to make it more readable. Readability is very important, and commenting as well. So if you want to talk about comments, so you have opening and closing curly braces. We talk about that. Now, between the opening and closing braces, you have your statements. This is what your code is, and here we're calling the printf function, which is found in the stdio.h library file. So we've seen what a format of a function. Typically, it's a function name. So you have a name and then the opening parentheses and the closing parentheses, and inside it you have the input that you're passing to that function. So at some point you will write your own functions in C, and it's going to be very similar to that. You have a function name which you would give, and then you're going to pass some inputs to it. It's going to do some processing and return something back to main, or send something to screen, or send something to text file. It basically do some tasks for you. Now, we've also mentioned about a slash and wildcard here inside the printf. So this one basically changes line. You have other wildcards like slash D is going to allow you to put tabs. So as we go along, we're going to come across these wildcards. Important here, what I'm trying to stress here is all your statements in C is going to end with a semicolon. That's important. If you omit this semicolon here, you will get an error. So you can just try this out. Okay, so this one is giving all the various functions of all different lines. So we've talked about this already. The first one is the header file and the main function, and then it's opening curly brace, closing curly brace, and then you're having call from the main to the printf function found in stdio.h, and just to print the message on the screen. So if you just make a simple program like this, now you modify, now instead of only one printf, you're putting 3 printfs. The first one is hello, semicolon. The second one is just world, and the third one is printf with a wildcard on them. So you can call printf functions on the wildcards, you can change the line. So if you run that piece of code, you find you get exactly the same message. Why? Because this first printf, so the header file is the same, the main, opening, curly brace, closing curly brace, that's the same thing as before. Now this printf is simply printing hello with a space here. So a space is very important. You're leaving a space after the comma here and before your double inverted comma for the printf function ends, and of course all the printf will have a semicolon, and then there's no change of line. So on the same line, he's going to print world here without any spaces, and when it comes to third printf, he's changing line. So you get exactly the same message, the same function that we've seen earlier. So next topic we want to look at in our overview of C programming languages are variables and arithmetic operations. And we're going to do that now with a simple program that's going to convert our temperatures from degrees Fahrenheit to degrees Celsius. So we need that's a formula. If you have a temperature, for example, in degrees Fahrenheit and you want to convert it to degrees Celsius, that's what you need to do. use a formula here to calculate. So we want to write a very simple program that's going to give us some output like this. So the first column here are your temperatures in degrees Fahrenheit, and these are the temperatures in degrees Celsius. So we want to automatically do that. The starting value for our temperature in degrees Fahrenheit of 0 until 300 is depth of 20. And for each particular value, we want to calculate this corresponding temperature in degrees Celsius and put them this way. Of course, on top there, in this particular output, you don't have any label for the columns, but you could add a column, for example, say this is degrees Fahrenheit and this is degrees Celsius, much more informative. So as we look through this program here, we're going to introduce some further concepts. So we are learning by doing here, not just introducing the concepts in theory and that's applying. We are looking at practical programs and then discussing the features. I think this is much more provides a better learning outcome as opposed to just going for theory. So let's look at the program here. Definitely there'll be new concepts again, which we'll discuss. So let's look at this program. First thing we want to discuss is what are the elements we've already seen in our very simple program we've seen earlier for the hello world. So first thing we've already looked at is the hash include stdio.h. So this one is including the header file. So why we're doing that inclusion? Because you're using Printf. So to be able to use Printf, that Printf should be located somewhere. It is found in this header file. That's the first thing. Now, what other things which we've seen in our hello world program, you can find main. So forget about this line for the time being. So we have a main program, an opening curly brace and a closing curly brace here. So this one is corresponding to this one. Okay, now we have a series of statements here, which we'll look at in a few minutes. So what else did we find in the hello world program, which is common here, is all your statements you have here are and the semicolon, except for the while here. You don't find any semicolon after the while, so we'll discuss that. And then all of the statements here ends with semicolon. If you look at Printf, like we discussed earlier, you have an opening parenthesis and close parenthesis, and then inside it you have some arguments. Yep. And then you have a double inverted comma, but this one is a bit different here. You have a comma, and then you have some names of some variables. Okay, so let's go ahead and try to look at these various elements which are new to this program, which adds on to our hello world program. So first thing we found that we have this line on top here, which is in Printf Fahrenheit Celsius table and give some values. So this is actually a comment. So in C, you have two ways to write comments. So first one, this one, the block comment means it starts on one line and ends on another line. So this is how you do a block comment. You put a backslash and then asterisk, and then you start writing here. Now this one's a block comment means as long as you don't have the asterisk and backslash again, it's going to keep commenting. Yeah, so it's a very nice way if you have a piece of code in the future which you also just want to take out from the compiler for some time, you can just use commenting. So but basically, comments, of course, are used to provide information to you as a programmer or the users of your code later, which gives information what actually this code is doing. It could be at high level here. Just go back. It could be at high level here, means when someone is looking at the code, say, yes, this program is actually converting my Fahrenheit to degrees Celsius, but you can, of course, comment on line by line here. So this line is saying this is a lower limit of temperature table. So we are starting at a lower value of 0. And it's the upper limit of temperature, which is 300, and you are actually incrementing in steps of 20. If you look back on the table we had earlier, so you're starting at 0, you're ending at 300, and you're incrementing by 20 every time. So this is what this line is saying for informative. I can say, so these are comments. When you compile this program, all these comments would not be part of the machine code or the execution. The comments are just for you as a user or for future users of the code who actually accessing the code and looking what you've done. Okay, I hope it's clear. So the commenting is, this is how you do it. The second way you can comment is if you're doing line comment here, if you put double of the slashes here, then you're doing line comments. They're very useful if you're doing only a comment for one line. You can just start it with the two double slashes, and you don't need to pay it as well. This is for line comments. Okay, so we've talked about that, and we've also seen other comments. Yeah, so these are also comments to help you. This is very useful when you're writing programs to always put comments. Don't overdo it, don't put too many comments. So your comments are at your own discretion how many you want to use them, but basically it's to make your code more readable yourself or people who are using the code in the future. Now, next thing we've seen in this program, again, which is adding up on our Hello World program, are variables. So here we're using some variables to store the initial value I want to start off, the lower limit, the upper limit, and the steps. You can see here we have three variables, lower, upper, and step, and we also have two further variables. One is storing the temperature in Fahrenheit, and the second one is the temperature in Celsius, which we're of course calculating from FHR. Now, what actually is preceding these various names here are the keyword int. So both lines have int. So this int here is simply saying that these variables for time being are integers, so they can store decimal point numbers. So if we go back to our program again, so we start our main here, and after our opening curly brace, we have a series of declarations for variables. So you're giving names to these variables. At this point, when you declare these variables, they don't have any value yet assigned to them. It's afterward that we start defining them. So very important for variables, you have variable declaration and variable definition. So this is variable, for example, here int lower, you're declaring a variable called lower. And here you're giving a value of 0 to it. Same thing for upper. Here you're declaring a variable called upper, and you're here assigning 300 to it. Same thing for step. You're declaring a function integer, int of type int, and then you're giving a value of 20 to it. So this is a function declaration, a variable declaration, and here's variable definition or assignment. Okay, so we're going a bit more into variables now. We know definitely as engineers that we need, and for mathematical formulas, we need variables to store numbers into it and to do some computations. So very important for us to be able to use variables. Now, what's the implication of defining a variable as type integer? So it's very clear. So in C, when you want to declare a variable as type integer, the keyword is int. Remember, we talk about reserved keywords. So int is a reserved keyword in C. It means you can't declare a variable called int. For example, here you can't say int, because int is a reserved keyword. So you can't give a variable name as int. Now, other implication of defining a variable of type integer is an amount of memory space stored to it. So typically, it depends on the machine you're working with, on the laptop or computer you're working with. Typically, it could be 4 bytes, it could be 2 bytes. So we're going to later see how can you actually find out how many bytes are stored for different variable types. So we're going to come back to this. So variable as a type int means that the variable listed are integers by contrast with float. So if you want to define here a number which has decimal point numbers, let's say 2.5, 3.6, then you can't use int, you have to use float. So the type or the reserved keyword for decimal point numbers would be float. Now, implication of defining a variable to be of type int and float also defines the range of that number. So if, for example, if you have an integer with 16 bits, and 16 bits are 2 bytes, then you can store a number from minus 32,768 to plus 32,767. Whereas if you have 32 bits now, means 32 bits is 32 divided by 8, because we know 1 byte is 4 bits. So if you have 4 bytes amount of space to store any part of number, it can be now very large. Now this is very, very large. Small number if it's positive, and a very large number which is positive. So of course, the more number of bytes or bits you can allocate to a variable, the more number of precision, the more range you have, it of course, the more computationally intensive will be your memory, be your program, because it needs more memory. Now, what are different variable types you can use in C? So as for those, so characters, only one single character. For example, it can be A, B, C, D. We're going to come back to that later. We have a method to actually assign characters and give them, of course, their bit equivalent, because we know all numbers are stored as bits, zeros and ones. So we're going to look at that's called ASCII convention. We're going to look at that later. So again, a character is just a single byte, just 1 byte with 8 bits. Okay. Now, next type, these are a few of them. Short. So if you use a keyword short for the data type, it means a short integer. A long is a long integer. So why short and a long? So you could be reserving more number of bytes for your integers as opposed to an integer itself. The size of these objects are also machine dependent. So we're going to look at later a single program which allows us to find the number of bytes for any type. So double precision floating point. So typically, if you use float to store to declare a particular variable, now if you use double, you can store decimal numbers. decimal point numbers, but we calculate even more amount of memory space means you can have more precision. We know precision is very important in calculations, mathematics. If you're iterating, you don't want to use accuracy. So this is where we're going to start using double. So once variables are declared, they are assigned to values. Starting in this case here, you have lower is go to 0, upper is 300. But before you're able to actually use these variables, you need to declare them. If you don't do that, then your compiler flags an error. Now we've seen earlier all statements against and this semicolon. Now each line in the table is computed in the same way except with different values of temperature. This is implemented using the while loop. So what while loop actually is doing when your code is starting, so if you just go back to the main program, now it's going to be clearer. So you can see here we're declaring all your variables. Here we are defining them. And then at some point we say FHR, which was the variable we're using at this point, of course, all our integers. Later we'll see what implication of having temperatures in integers. We lose accuracy. And we will do also run in some problems, which we try to address later by using float. But to start off using integers here, so these three variables, lower, upper, and step, have been already assigned to values here that we define, and that's suppose the FHR is going to lower. So FHR, which is the variable you're using to store temperature in Fahrenheit, is currently having a value of 0. So at this point, FHR is 0. And then we step into this while loop. So the while loop basically is a loop which is going to repeat itself as long as a condition you have inside the parentheses is actually true. So at this point, so just memorize this. So at this point, your FHR is 0. So while 0 is less than or equal to upper 300. So as long as the number of the value to store in FHR is less than or equal to 300, this while loop is going to keep running. Now, where the while loop starts and ends, it starts here and ends here. You have an opening curly brace and the closing curly brace. So this is why now you have a semicolon for your while loop, because the while loop doesn't stand on itself. It has statements that are within it. So the while here is not a statement itself, it's a construct to repeat statements. So you don't have a semicolon after here. Okay, so once we have already assigned a value for FHR, which is 0 initially, and then we check is 0 less than or equal to 300? Yes, it is true. So as long as it's true, we will step inside this code and run this. So what we actually do once FHR is 0, so then we calculate the value for Celsius. So Celsius is going to 5 multiplied by the formula we've seen earlier. So this value is going to be 0, and we get a corresponding temperature for Celsius. Now let's put a printf statement here. Now we've seen that over earlier, so you have a double inverted commas here, and then earlier we had hello world here. But now in this case, we don't want just to print some fixed text. We want to print the value of a variable, because FHR and Celsius, these two variables, would have different values at different points in time as running in the while loop. So it means how you actually take these values and print them in a dynamic way as it's changing. You use a percentage D. Percentage D is for the format specifier. So percentage D is for integers. If you had a floating point number, it would have in percentage F. If you have a double point number, it would have in percentage G. If you have a character, percentage C, or string, percentage S. So all these are format specifiers. So basically what are we saying here, when the compiler is going to come across this printf here, the percentage D, this is saying here, we want to print the value of an integer. Slash D is a wildcard for temp, so it's going to leave some space in between. And then the second percentage D means you want to print the value of a second integer. And then slash N, we've seen it the change line, and this is the closing double inverted comma. And you have a comma here because we are putting percentage D, percentage T. We have to say now which integer variables we want to print. So FHR, the first percentage D that we have here, the first integer is FHR. So it's going to take the value of FHR, which is currently 0. It's going to put here. The second percentage D is Celsius, which we've calculated here. It's going to take its value and put it here. So that's what the printf is. The printf is not just for static text or text which are just fully defined. It's for any dynamic numbers as your code is running. If you have variables inside there, you want to print the values of these integers, then you would use format specifiers and then give the name of its variables. So this is expanding now the print function to what we had in the hello world. Yep, so this line here is printing the value of FHR and Celsius as they are at the bottom of the point in your while loop. And this line is very important. Remember, your FHR started at 0. Yep. Now, if you don't update your FHR, what is going to happen is going to stay 0 is less than or equal to 300. If you don't update it, this is going to be true always, then your while loop will never end. You can identify that. So this line is basically saying here, FHR is currently 0. Now I take 0 plus 20. So this was a step which can change, of course. Now the new value is stored in FHR. So the previous value of 0 is overwritten by 20. Now you come back to your value and you check, is 20 less than or equal to 300? That's true still. So then you calculate the value of Celsius for 20, you print it, and then you update it to 40. So this while loop here is going to run until FHR becomes 300. So is 300 less than or equal to 300? Yes, because you have equal to sign here. That's again true. So it's going to calculate the value of Celsius corresponding to 300. Print it and now update 300 plus 20, get 320. Is 320 less than or equal to 300? No, it's greater, so that's false. It's not going to run this code, it's going to step out and end your program. So if you run this simple piece of code here, which I encourage you to do, you should be able to get a table like this. Okay. So as you read through these different lines here, it's going to become clear what's doing. The while loop is what we've just said. The while loop is executed many times until the condition becomes false. So very interesting exercise for you to do manually. So labeling the first time the while loop is executed as iteration 1. Work out the subsequent iterations, giving the value of each variable until the condition for the while loop becomes false. So try to do that on paper. Start with iteration 1, where your FHR is 0 and the first values that you have. Calculate now the corresponding value for Celsius on the calculator, put it there, and then your FHR becomes 20. So keep doing that until your while loop ends. So when the test condition becomes false, the while loop ends and you come out and then you just run. Now, the piece there in green, so I would encourage you to do that now in your piece of code. This is where I'm stopping this lecture series, this first video here on the overview of C programming language. So the part in green here, I want you to give it a try. So can we take the difference and then multiply by 5/9? So can you take FHR minus 32 and then you multiply by 5 divided by 9? So give it give it a try in your code and see what happens. Okay. So we'll come back to this next time in the next video. Thank you very much.